So this is the example. This is example number 6 in the 9B notes. And in example number 6, we're just told to use the chart that we filled out in example 3. So if you're not sure how to fill out this chart, go ahead and just check back with the example 3 video. Okay? So let's just go through this problem. The first part of the problem wants to know what's the probability that someone in our sample space drives a car to work. Okay? Survey of 100 people. Okay? So here's our big total of everyone in the sample space. And as you guys know, when we find probability, we want to find of some category. We want the number that's in that category. And then on the bottom is that total number in the sample space. Okay? So we want to find out how many drove a car to work. And probably the biggest mistake students make is to use this number. But remember, car means everyone in the car circle. Okay? Everyone in the car circle. The car circle includes all of those people, even the people who also rode the train. So that's our car total, not just this part. So the number that we're going to write for that top number in our probability ratio is 60. Okay? What about on the bottom? Well, that's our total number of possibilities. That's 100. Okay. Part 2 wants to know what's the probability of someone in our sample space taking the train to work. And guys, that's the same idea. A lot of people want to put that number. But all the train people is everyone in that green circle. And that's why I like to put that train total on the outside, because it includes people who just took the train, but also the car people who took the train. So there's our train total. Okay, so the number in the train category, that's 20. And then our total number of possible outcomes, again, that's our big total. Part 3 wants to know, well, what's the probability that somebody took the train to work and took the car to work? Okay? And when we look at that category, train and car, we remember the and in a Venn diagram when we have two different subsets we're looking at. And means that it's those elements that are in both of those subsets. They're in A and they're in B. That's where that and comes from. Okay? So our and people for train and car, we have 10 of them. And we're still over our total number of possible outcomes. Okay? So I'm just going to clean up here 1 second and we'll rewrite that. So 10 over 100 for train and car. Well, now part 4 asks, are riding the train and driving a car independent events? That's the question. When we're trying to figure out if two different events are independent or dependent, we have this formula, right? We find the probability of the first event and then multiply it times the probability of the second event. Again, this is multiply. And then we ask that question. Is it equal to the probability of A and B? So that's what we need to set up for this question, okay? And I always like using this little template. And I've got this already set up for this problem, okay? Our P of A, that's the probability of our first event. Well, our first event is taking the train to work, right? So we want to take the probability of taking the train to work and multiply it. That's our first event, train. Okay, that's our P of A. This is event A, and this is event B. Okay? So the probability of taking the train to work, we're just going to go back up, and we're going to see that we already found the probability of taking the train to work. It was just 20 over 100. Okay. Then we're going to multiply it times the probability of taking the car to work. And we already found that. And that was 60 over 100. And then we're asking a question. Does it equal the probability of taking the train and the car? And again, we found that already. And that's 10 over 100. Okay? So we're trying to figure out, do these sides equal each other? And in order to find that out, we have to simplify the two sides. We have two fractions that are being multiplied on the left side. So we need to go ahead and multiply those fractions. And remember, when we multiply fractions, we multiply the top numbers, and then we multiply the bottom numbers. And when we multiply the top numbers, they go on the top of our new fraction, and the bottom numbers go on the bottom. Okay? So let's do that. And we're going to just do that on a simple calculator. I'm going to take this number times the next top number, 20 times 60. And that's going to give us 1,200. Now we're going to take the bottom numbers and multiply them. 100 times 100. And anything times itself is just that number squared. And you'll see that gives us 10,000. And then we're asking that question, does it equal 10 over 100? Now, these numbers look pretty different, but remember, we want to find out what the decimals are because it's easier to compare them when we know what the decimals are. Okay, so we're just going to go back to our calculator and we're going to take 1,200, this first fraction, we're going to divide 1,200 by 10,000. 1,200 divided by 10,000. And we're going to get 0.12. Okay, now we'll do 10 divided by 100. And we get 0.1. And we're rounding to two places, so we'll throw in that second zero. So now we're asking that question, do they equal? And when I look at 0.12, and I ask myself, does it equal 0.10? They're close, but they don't equal. They do not equal. And so when we write our answer, we're going to have to say, don't equal, they're not equal. And when they're not equal, we know that those two events are dependent events. That means that they do relate to each other. The probability of driving the car and the train, those two events are related. Okay, those are dependent events. They affect each other. Okay, so that's how we do independent and dependent problems. Guys, thanks for watching.